Here is your video for solving quadratic equations, focusing on the method of solving by factoring. You've dealt with linear equations before. Those are equations where we'll find our variable with no exponent. We know that when we don't see the exponent, it's technically a 1, but we don't see it written. We see just a regular x, and we can see some constants in there. These are some examples of linear equations. And to solve these equations, we usually work to get the variable isolated on one side of the equation with all the numbers to the other side of the equation. That's our approach for solving linear equations, but we have to do things differently when it comes to quadratic equations. The number one clue that we're dealing with quadratic equations is that we have an x squared. We will often have also terms with regular x, but definitely we need to see the x squared. And it's possible we don't have other terms with a regular x. These are three examples of quadratic equations. What really makes us have a quadratic equation is that we can write it in this form: ax squared plus bx plus c equals 0. And a, b, and c will always have numbers there. Those letters stand for our coefficients. So in this example, x squared plus 7x plus 12 equals 0. We would say that a is 1, b is 7, c is 12. That's one way we can talk about these quadratic equations. One main reason that we need to solve quadratic equations by writing them in this form is because it's not really possible to isolate the variable. How can we combine these two terms to try to get the x all by itself on one side of the equation? So I think that's really our number one way to see that ways of solving linear equations do not work to solve quadratic equations. Let's work in another idea that comes into play: zero product, zero factor. It's a property, or let's call it a rule. Basically, if two things multiplied together equals 0, then it means you started with 0. If x times y equals 0, then either x equals 0 or y equals 0. So if you have a product that's 0, you definitely had a factor that was also a 0. The only way you can multiply numbers and have it equal to 0 is if one of those numbers you started with was 0. And it's also possible that they're both 0. So the rule that we're going to see is that when we come to a part where two things multiplied together equals 0, we know we can split them up and say, oh, maybe that first part equals 0, or maybe the second part equals 0. And we'll keep in mind that it could also be both. The idea you've seen before. Here's a linear equation that you might have solved. 5x equals 0. We would work to isolate the variable x. Right now it has times 5. We'll do the opposite. Divide by 5 on both sides. The 5's cancel. We have x. The right side, 0 divided by 5 equals 0. X equals 0. So that's a way that we would solve it in the past and get to our solution, x equals 0. But this zero product, zero factor rule is something that takes us to the same answer a little bit quicker. 5x equals 0. We're saying here are two parts multiplied together. 5 and x multiplied together equals 0. The only way we can multiply things and have it equal 0 is if we started with a 0. And that one's a 5, so that one would have to be a 0. So that's the other main idea that we will be working in to our methods for solving quadratic equations by factoring. Let's look at an example. The equation is x squared minus 5x plus 4 equals 0. The setup is great. What we want to notice is that the terms are in descending order. They are all on one side of the equation, and it equals 0. When it's in this setup, it means we are ready to factor. So think about not the equals 0, but think about these terms on the other side of the equation. What are our steps for factoring? What is the pattern? All those ideas that we use for factoring, they come into play right now. Three terms where our leading coefficient is 1. So it's the simpler sort of trinomial. We look for a pair of numbers that multiply together equals positive 4. Added together, they will equal negative 5. And that pair of numbers, negative 1 and negative 4. So that's the factoring part. Now, we get to work in this zero product, zero factor rule. Because at this point, are we saying that two parts multiplied together equals 0? What are those two parts? There's one part, and there's the other part. X minus 4 times x minus 1 equals 0. And if two things multiplied together equals 0, then either x minus 4 equals 0 or x minus 1 equals 0. That's how we're using the zero factor, zero product rule, and we finish this problem by solving two linear equations. A neat way for us to go from a quadratic equation down to two different linear equations to solve. And we finish, just like a linear equation, work to get the variable by itself. Add 4 to each side. Takes us to our first solution, x equals 4. We need plus 1 on each side here to cancel with the x minus 1. To cancel the minus 1, leave the x behind. X equals 1. We have two solutions, x equals 4 and x equals 1. Well, let's check these solutions. Let's check back to our original equation, x squared minus 5x plus 4 equals 0. Let's check x equals 4. In place of each x, we have a 4 in parentheses, and we would like to see, when we evaluate the left side, will it equal 0? We'll follow order of operations. Exponent 4 times 4 is 16. We'll skip the subtract and do the multiply. 5 times 4, 20. And now, from left to right, doing our subtract and then add. 16 minus 20, negative 4, plus 4, 0. 0. We do get a check. So 0 on the left side to match up with 0 on the right side is indicating that x equals 4 is definitely a solution. Let's check x equals 1. Back to our original equation, in place of each x we have a 1. Order of operations, 1 squared is 1. This 5, negative 5 times 1, negative 5. And from left to right, 1 minus 5 plus 4, that's negative 4 plus 4, does equal 0. So two solutions, and they both check. And that's a theme that we will see with quadratic equations, that they give us two solutions. So we're prepared for that. And to write our answer, we're often going to write a solution set. We basically use these braces, the curly brackets, and inside those we write a list of all our solutions. The order doesn't matter, so 1, 4, or 4, 1, and it definitely is not an ordered pair. It has nothing to do with x and y and graphing or plotting points. It's just a list of our solutions. So there is our solution set, which includes the two solutions we found, positive 1 and positive 4. Here's an example for you to try. Pause the video, work through this example, then come back to the video and we'll go through the answer. The first thing we want to notice is, do we have it in the proper form? And we do. We have all of our terms together on one side. They are in descending order. Our equation equals 0. Our setup so far is great. We're ready to factor. How do we factor this trinomial? The leading coefficient is 1, so we just need to think about, what is that pair of numbers? Multiplied together would equal negative 8. Added together will equal negative 2. That pair of numbers, negative 4 and positive 2. And now we can spot the two parts of this equation that multiplied together equal 0, so we can split up into individual equations that equal 0. X minus 4 equals 0. To solve this, we're adding 4 to each side. Takes us to x equals 4. This equation, subtract 2 from each side, takes us to x equals negative 2. And we have our solution set, positive 4 and negative 2.